Okay, in this video, I'm going to show you some of the popular questions for A-level and S-level physics. Let's see question number 1. Okay, this question is related to force, density, and pressure. A uniform horizontal beam OS, 4.0 meter long and weighing 100 Newton, is hinged at the wall at the point O, is supported by a cord SY which is attached to the wall at Y. Okay, so normally what we do is we have to label the direction of the force. Okay, this is a tension in the spring in the cord, so this is T. And then we know that the weight of the rod, since it's the uniform, you have to pay attention to this word uniform. That means the weight will be acting at the center of the this beam, so it will be exactly 2 meters away from this point O. Okay. And since this is in equilibrium, so what you need to do is you have to take the moment about point O. So this one is a concept of equilibrium of rigid body. That means the clockwise moment will be equal to the anti-clockwise moment. So the clockwise moment, so we just have to consider, don't bother about which one is clockwise and anti-clockwise. That's why we can see that the T will produce the moment turning this way, then the other one is turning the other way. Okay, so we know that turning this way is called the anti-clockwise, and this is the clockwise. Okay, so after that you just have to put in the value. This one you have to resolve vertically, so this is T sine 30. Okay, and then multiply by the distance from the pivot point, which is 4. Another one is 100 turning downward, so this 100 Newton. Turn downwards, the distance is 2 meters. So what is the T? Okay, so you get your calculator, 200 divided by 4 divided by sine 30. Okay, make sure that your calculator is in degree mode. So this one will give you 100 Newton. Is it correct? 100 Newton. Okay, answer will be D. Okay, the next question. The data below, okay, this is related to work, energy, and power. The data below taken from the test of the petrol engine for the motor car. Output, this is output. This is fuel consumption, 20 liters per hour. Then the energy content of the fuel is 40 megajoule per liter. Okay, you need to find the ratio. Okay, we are looking for the ratio of output to input. P out over P in. P out output, this is very simple, it's 150. Okay, kilo is times 10 to the power of 3. Input, you have to see this is fuel consumption, 20 liters. So you are not sure, then you just have to put in the unit, 20 liters per hour. This is per 1 hour. 1 hour normally we have to convert to 60 minutes, 60 seconds. Okay. And then this one is 40 mega is 10 to the power of 6 per 1 liter. So we can see that this one on top, this is a joule, this is second, on top is watt. Okay, so you have to be careful with the unit, and then these two can be cancelled out. The liter and liter can be cancelled out. And what you need to do is just to rearrange the equation, 150,000. And then these two divide, you know that 60 you have to bring to the numerator. So 20 times 40 times 10 to the power of 6. Okay, after that you have to look for the correct answer. It's like that, oh, B is the answer. Then you have to circle B as the answer. Okay, done. Question 3. This one is a spring constant. This one related to Hooke's law. It's joined together with another spring whose spring constant is 4 Newton per centimeter. The load of 80 is suspended from this compressor spring. Okay, how are we going to do this question? Okay, there are two ways of doing this. First one, if you can find the combined spring constant of this, because this is in series. If in series, normally we can use 1 over K equivalent equal to 1 over K1, 1 over K2 to calculate the equivalent spring constant. This is 1 over 6 plus 1 over 4. So what is the value of the KE? So 1 over 6 plus 1 over 4, and then reciprocal of this value is 2.4. Okay, so we can find that this is actually 2.4 Newton per centimeter. And then you can apply the Hooke's law, F equal to Kx. We are looking for the extension. So S is actually the ratio of F over K. The force that we apply is 80 Newton. So 80 divided by the 2.4. So after you divide, you find that 80 divided by 2.4 will give you 23. Okay, so the answer will be D. Okay, maybe you ask, is there any other way to do this? Also, there's another way. Because the load, because this is connected in series, that means every spring will experience 80 Newton. Every spring experience at 80 Newton means for spring number 1 is K1 S1. So we can find the S1 by finding the ratio of F1 over K1. And then the same thing applied to the second one. The same force will be acting and the spring constant and S2. So we can find the S2 by finding the ratio of these two. So the load will cause spring number 1 to extend, spring number 2 also will extend. So both of them extend, that means we are looking for the total extension, so it will be S1 over S2. Force number 1, so we need to know that 80 Newton will be acting at the first spring as well as the second spring. So for first spring will be 80 divided by 6. The second spring is also 80 divided by 4. So let's check together. Are they the same thing? Is it 80 divided by 6 plus 80 divided by 4? Oh, it's the same. So that means there's either use approach number 1 or approach number 2, or both of them will be ended with the same answer. Okay, that's done. Okay. And oh, this is a bit complicated. So let's study carefully. The straight tube is closed at one end and the loudspeaker position at the open end. Oh, this one you have to imagine this is a pipe, tube, closed end. One end is closed and then the other one is open. Frequency of initially is very low, increase slowly. A series of loudness of maxima are heard. The stationary will give the first maxima note at the close. Maximum has a note at the closed end and anti-note at the open end. It means they're telling you that at the closed end is anti-note and the open end is this. This is first maxima. So we have to find the fourth maxima. First maxima and fourth maxima, what is the difference? So we can derive this formula because of this one. You have to consider the length of this pipe, which is L, and this one will form A to N. Anti-knot, the distance between anti-knot to knot is 1 over 4 lambda. Okay, it's 1 over 4 lambda. So V equal to F lambda, so we can find the corresponding frequency for this. Okay, it's a ratio of V over lambda. This one you have to put this one as L. That means from first part we can see that the lambda is actually 4L. So you form V over 4L for the first one. And then we can go on and try the second one. In the same tube, if it's the second resonance, it will be forming because of due to this one, the standing wave. So we can see that the distance L inside here, this should be here to here. We can see that this is actually 3 over 4 lambda. So this 3 over 4 lambda, what does it mean to us? Means now the L has become 3 over 4 lambda 2. So this one is wavelength for second standing wave. So this is 4 over through L. And then you can use the same way. F2 is V over lambda 2, so it's V over 4 over 3L. V over 4 over 3L. So what does it mean? Means this is 3 over 4 V over L. So what we can see here is you can see that for first one is 1 over 4 lambda. The second one is 3 over 4 lambda. So this is 3 times of the second one. So actually this one we can draw a conclusion. That means the first lambda is F1. Okay, second lambda is actually 3 times of the first lambda. 3 times. We can see that this is 3 F1. Okay, 3 F1. Second one is 3 F1. Then the third one will be 5 F1. Then how about the fourth one? Because this one you can see that this is all the odd series, all are odd number, 1, 3, 5 are odd numbers. And then when we come to the fourth one, we can see that this is actually the 7F1. So first one, second one, third one, fourth one. This answer will be D. Okay, this is how we can get the answer for this part. Okay. Okay, number 4. Okay, number 4, this is the Doppler effect. Buzzer emitting the sound or frequency of 846 attached to the spring and rotated in the horizontal circle. The linear speed of the buzzer is 25. The speed of the sound is 340. What is the maximum speed heard by the observer? Okay, so this one is rotating in the horizontal circle. So as well, what we can see if you view from top, okay, we can see that at certain time, okay, this is turning in this way. So we can see that at certain time, this object will be moving towards the observer, and certain time it will be moving away from observer. At certain time, it will be moving up, and certain time it will be moving down. So this is actually related to something called Doppler effect. Doppler effect tells us that the frequency of the observer observed frequency will increase when the this is considered source, because this one is giving off the sound. So when the source is moving closer, the observer will cause the frequency of the source to increase. So there are two scenarios, either the frequency increase or frequency decrease. And now we are looking for maximum frequency, so we have to look for the frequency increase. So we know that this one will be, you have to apply the formula. Frequency observer is Fs, this is the original frequency of the source, V over V minus Vs. So you have to use this formula. How to apply this formula is very simple. You have to know the frequency of the source. Frequency of the source, this is the source 846, and then the V is the frequency of this is the speed of the sound 340, and then there's one more thing is the speed of the buzzer. Buzzer is moving, so this is the speed of the source. Okay, after you get ready for everything, you have to substitute the value 846 and then multiply by the speed of the sound 340 divided by 340 minus the speed of the source, which is 25. Okay, so from here we can get the value 846 times 340 divided by bracket 340 minus 25. Okay, we find that the frequency, the new frequency will be 913. Okay, so we can see that the frequency is increasing. So if you don't count, also we know the answer must be one of these two, because when the object is moving towards the observer, will cause the frequency to increase. So obviously the answer should be D. From calculation, we already verified this will be D. Okay. Okay, now we go to this question number 5. This is a DC circuit related to this parallel circuit. So this one, there are 3 resistors connected in parallel of the power supply. So the power source, power dissipated for each one of them is 2, 3, 4. Okay, P2, P3, and P4 respectively. What is the ratio of this? So for this one, the most important concept for parallel circuit is we need to know that all of them will be receiving the same potential difference. So same potential difference for parallel circuit, same potential difference. So since this is having the same potential difference, means all the V are the same. V1, V2, V3 are all the same. Okay, so this is very important, because once you know this one, the potential difference is the same, then because the power, there are 3 formula, so we need to know which one is the most appropriate one to apply. Okay, so if it's same potential difference, and then this one only left with the resistance, that means you have to choose the second one. Okay, because the second one will tell you that the P is inversely proportional with the radius. So when you're finding the ratio of P2, P3 to P4, that means it will be inversely proportional ratio or the resistance. So for number 1 is 2, so it's 1 over 2 to 1 over 3 and then to 1 over 4. Okay, then what we need to do is when we want to convert this one to the number integer, you have to multiply by the LCM. LCM of this one, we can see that 2, 3, 4. What is the LCM for 2, 3, 4? Okay, will be 12. You have to multiply by 12 for every one of them. So you find that the first one will be 6, the second one will be 4, the third one will be 3, and then you have to look for the correct answer. Answer will be C. Okay, so we have 6, 4 and 3 for this question. Okay. Okay, the last question that I need to show you is about this DC circuit related to the potential divider. Circuits, the circuit shown consists of two resistors, resistance 10, 50 and a component of Y. So there's a component of Y. When 6 volt is applied, the characteristic potential or the bottom is 0. So this point is 0. Current into the component Y is negligible. So this one we know that when there's no current flowing to this one very likely will be the voltmeter. Okay, it's going to be the voltmeter. So ignore this part. Okay, and then we need to find the electric potential. Electric potential is V. Potential difference is different. So electric potential means we have to find the Vs at this point. Okay, so what you need to do is when the energy is supplied to the first component, you cause the potential to drop. So we need to find the potential difference between this point and this point. So potential difference is equal to potential difference. You can also use a potential divider to find the potential difference. Potential difference will be, we have to use R1 over R1 plus R2 multiplied by V, the supply. So for this case, potential drop. So we have to think about which one having the lower potential. 6 volt and this Vs, Vs will be having lower potential because the energy is dissipated by this resistor. So it causes the potential to drop. So with this one, we have to use 6 minus Vs equal to the 10 divided by 10 is a resistance of 10, and then this one is 50, so it's 10 plus 50. And then you have to multiply by the total voltage supply, which is 6. Okay, so now you have to solve this equation. As what we can see, this one is 60 over 60, and this is 1. If this is 1, Vs will be 6 minus 1, will be 5 volt. Okay. What if you don't want to use this way? You can use another way, also can. Another way is if you want to consider the other one, also can. You have to consider the potential difference between this point and this point. So, and we know that S has a higher potential because the energy comes from upper side to the lower side. It's flowing this way, your current is flowing this way. So when you take Vs minus V0, okay, you can just write Vs minus 0 is going to be the potential difference. This is 50 and then divided by the total resistance. This 50, I'm just applying the potential divider rule. So this is 50 and then 50 plus 10, and then you have to multiply the power supply, which is 6. So from here we can also get the same thing. This is 300 over 60 and this is 5. Then Vs will be also 5 volt. Answer will still be number, will be D. Okay, thank you for watching.